Okay, so the elimination method is another algebraic method you can use to solve a system of equations. The goal of this method is to eliminate one of the variables by adding the equations together. So as we go through, our first step is to make sure that we multiply one or both of the equations by a constant to obtain coefficients that differ only in one sign. So that means we want to end up with something like a 2x or a negative 2x. The second step is to add them together so that one of our variables drops out. And then our third step, after we have that value for x, we're going to plug it back in to solve for the other missing variable, so x or y. So here's our first equation here. We've got 3x minus 2y equals 31 and 3x plus 2y equals 31. So if I look at this right here, these two are already opposites, our negative 2y and our positive 2y. So what I'm going to do is I'm going to add them together. So 3x and 3x is going to give me 6x. My y's drop out, which is what I want to happen, is equal to 30. Sorry, this is my first time using this slate and it's a little tricky. So I'm going to solve it. I'm going to divide both sides by 6. And I end up with x is equal to 5. And when I have that, then I'm going to pick one of my equations to plug this back into. It doesn't matter which one, but it has to be one of my originals. So I'm going to pick this top one right here. And you can pick the bottom one, it doesn't matter. So when I pick the top one, I'm going to rewrite it on the side here, 3x. But instead of the x, I'm going to write a 5. So 3 times 5 minus 2y equals 31. And once I have that, then I'm going to solve it. So I'm going to have 15 minus 2y equals 31. And I subtract 15 from both sides. I end up with 2y, negative 2y, sorry, is equal to 16. Divide both sides by negative 2. And we get y equals a negative 8. So remember, this is an ordered pair where these two lines are crossing. So I'm going to end up with the ordered pair 5, negative 8. And that's my solution. So that one was pretty straightforward. If I look at another one that maybe doesn't have two variable coefficients as opposites, if I look at this one, I don't have a 3y and a negative 3y, or I don't have a 12x and a negative 4x, a negative 12x. So when I'm looking at this, I'm going to figure out, well, what could I multiply one of the equations by so that those two drop out, those two coefficients. So when I look at this, I'm thinking I am going to multiply that top equation by a positive 3. And whenever I do to one side, I have to do to the other side also. So I'm going to multiply this by 3. So I'm going to end up with a 36x minus 3y equals 6. And then my second equation stays the same. 4x plus 3y equals 4. And now I've got two opposite equations here with my 3y and my negative 3y. So when I add these two together, I'm combining my like terms. I get 40x. My 3y's cancel out, equals 10. Divide both sides by 40. So I get x equals 1/4 or 0.25. Okay, so now when I go to plug that back in, I'm going to pick my second equation. Again, doesn't matter which one you pick, but I'm going to plug that in. So 4 times 0.25 or 1/4 plus 3y equals 4. 1/4 of 4 is just 1. Plus 3y equals 4. I'm going to subtract 1 from each side. So I end up with 3y equals 3 and y equals 1. So I end up with 0.25 for my x value and 1 for my y value, and that would be my final solution. Okay, we don't have two terms with opposite variables, so I'm thinking in my head, I want to get these 5x and 2x, I want to multiply them by something to get a negative 10x and a positive 10x, or I can look at the y's and get a negative 15y and a positive 15y. So I'm going to stick with the tens. So I'm going to go ahead and multiply this top equation by a positive 2 and the bottom equation by a negative 5. And when I do that, writing it to the side here, I'm going to get a 10x. Oopsie, sorry. What the heck? Okay, 1 second. There we go. 10x plus 6y equals positive 92. And this should be an x. Okay, down here, once I multiply these, I'm going to end up with a negative 10x and then a negative 25y is equal to a negative 35. And now I have two equations where my x's are going to cancel out because they're going to be opposites. So when I combine these two, I'm combining my negative 25y and my 6y. I'm going to get a negative 19y. And that's going to be equal to a positive 57 when I take 92 minus 35. When I divide both sides by negative 19, I end up with y is equal to negative 3. So remember, I am trying to solve this for x now. So I'm going to take my negative 3. I'm going to pick one of my equations to solve for. I'm going to choose this one. And I'm going to plug my y in, my 3 in for negative y. So I'm going to have 2x plus 5 times negative 3 equals a 7. And when I do that, I get 2x minus 15 equals 7. Now I can solve it for x easily. I'm going to add 15 to both sides, so I end up with 2x equals 22. So x is equal to 11. So I'm with the ordered pair. My solution is 11, negative 3. And don't forget, you can always check if these are correct by plugging them in, your x and your y, to both of these to make sure they work for your system. Okay. Let's see here. One more here. If I look at this, I've got a 6x plus 3y equals 7, and then a 2x plus y equals a negative 3. So I'm going to go ahead and multiply that second equation by a negative 3 to see what happens to my variable here. So I'm going to end up with, and I'll write it to the side again, a negative 6x minus 3y equals a positive 9. And the first equation, I have 6x plus 3y equals 7. Well, what's going to happen when I'm combining these? My 6's drop out, my y's drop out, so I have nothing over here, and that's going to be equal to 16. Well, nothing equals 0 equals 16. Well, what does that mean? That we have no solutions. So if you think about what this means when two lines intersect is what we're looking for. The intersection point would be my solution. So this right here, if I have two lines, this would be what we call a solution. Well, if they never intersect, we have no solution. What kind of lines are they? They are going to be parallel lines. So when we have no solution, we have a number equal to a different number. It's going to be a no solution, and that's because my lines are parallel. So to recap here, we can solve systems of equations by graphing. And again, here's my solution, the ordered pair where they come together. This is what it would look like if we graphed it. If we use a substitution method, we are plugging one value. We've got a y here. We're plugging this in for the y to get our variable to drop out. So here you can see it in red. Substitute it. They figured out what it would be equal to, got the same solution. And then what we've been working on today, the elimination method, we want one of our variables to drop out. We can multiply it by something if that doesn't happen naturally, and we solve it. Either way we get it, we're talking about the place where the two lines are intersecting. So choosing a method, we can choose the graphing method when it's pretty easy to graph and we've got both of our equations are in the y equals mx plus p form. The substitution method works out really great if I have an x or a y alone on one side of the equal sign. And the elimination method works when they're both in standard form. So last problem for today, at a home garden sale, so we've got a word problem here. People usually struggle setting these up, so make sure you're really paying attention here. At a home garden sale, Mark buys 3 rose bushes and 7 beds of petunias for a total of $114.75. So I'm going to let my X be rose bushes, my Y be petunias. So I'm going to set my equation up of 3X plus 7Y equals $114.75. Okay, and then we have Cynthia, and she buys 2 rose bushes, so that's going to be 2X. 6 beds of petunias, so 6Y equals $89.50. Sorry for my bad writing here. Okay, so once again, I don't have any variables that are going to drop out. I want them to. So I'm looking at my x's, and it looks like I could get them to be a positive 6x and a negative 6x, and that would work pretty nicely to get that to drop out. So what am I going to do? I'm going to multiply that first one by a positive 2. I'm going to multiply the second equation by a negative 3. Okay, when we do that, I'm going to have a 6x plus 14y equals $229.50. My second equation, I'm going to get a negative 6x minus 18y and equal to a negative $268.50. Sorry. Okay, and again, I'm combining these. My x's right here are going to drop out. So 14y minus 18y, what am I going to get? I'm going to get a negative 4y. And then when I do have 229.50 and subtract 2, or combine it with negative 268.50, I'm going to end up with a negative 39.
So nice to keep that open so late.
Then I'm going to divide both sides by negative 4. And I get y equals 975. So what does that mean? If my y's were the petunias, each bed of petunias is $9.75. Okay, so I'm going to go ahead and plug that back in for one of the equations. I'm going to pick my bottom equation here, and you can pick whichever one you want, but it has to be one of your original equations. So I'm going to pick this one right here. Okay, and I'm going to plug that in for y. So 2x plus 6 times 975 equals my 89.50. Okay, now I'm just solving, and I end up with 2x plus 6 times 975. It's going to give me 58.50. And that's equal to 89.50. And when I subtract 59.50 from each side, I get 2x is equal to 31. So x ends up being $15.50. Okay, so I'm checking this, and let's see. Rose bushes at $15.50. That seems reasonable. Bed of petunias for $9.75. That seems reasonable as well. So to answer my questions, how much does one rose bush cost? One rose bush costs $15.50. How much does the bed of petunias cost? $9.75. So I hope this helped you understand this. If not, we will be reviewing a little bit on Wednesday when I get back, so we can talk about it then. And here is your assignment. Have a great night.